Welcome to Evo 10 ECU Flash Training Part 14. In this video, we're going to take a look at working with our idle control. Now the Evo 10s are a little bit different than an Evo 7, 8, and 9 applications. The Evo 7, 8, and 9s had a stepper motor for idle control where we command the stepper motor to open and close a certain amount to get the desired airflow that we're after, to get the engine to fire up and run and idle properly. Now with the Evo 10s, we don't have an idle control motor anymore. We have drive-by-wire throttle control. So we'll be doing our idle control using the drive-by-wire throttle plate movement to allow more or less air into the engine. Now in conjunction with this, we're going to be using spark timing feedback to be able to manipulate further the engine torque and the engine RPM so we hit the target idle that we're after. We're going to take a look at how the drive-by-wire throttle works with our idle control, as well as taking a look at the timing compensation and our base spark timing values for idle so we understand how all this is going to work. Without further wait, let's jump into this video so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our idle control and our Evo 10 ECUs. Idle control is extremely simple for an Evo 10 compared to something like an Evo 7, 8, or 9 where it had an idle control motor and we had to manage the number of steps the idle control motor was opening to give us the desired airflow so that we achieved our desired idle RPM. We're going to find that the idle control on an Evo 10 is all controlled through the drive-by-wire throttle body. Now there are some things that we need to factor in when we're evaluating our idle control, but generally speaking, if we're going to be setting a particular target RPM, the ECU is going to be doing all the background work for us to achieve that desired target idle RPM. So let's go take a look at our idle control here. We're going to find I have a 55580005 file open. If you want to open one of those up here to follow along, I'm going to jump in here to the current ROM metadata, and we're going to move down towards probably 3/4 of the way down here in our ROM metadata, and we're going to find we have a section here labeled idle. Now we're going to have a whole bunch of tables here to talk about. We're going to find we have our idle RPM versus coolant temp. We have an idle RPM adder versus coolant temp. We have a generalized target idle here, 1 through 16. And then we also have idle timing compensations table here. These are going to be something else we're going to talk about. So before we jump into these tables, I want to talk about how the idle control is going to function so it's very clear what we're trying to accomplish and what's going on with the ECU. We will take a look at some data logs. It's going to be backing up what we talk about right here in the first portion of the video and make a little bit more sense. So we're going to find, as I previously mentioned, that the drive-by-wire throttle body is going to be opening and closing the throttle plate in order to achieve a certain amount of airflow to produce a certain amount of torque out of the engine. When we're going into these tables here, if we jump into a target idle here, if we have our target idle here set at something like 900 RPM, the ECU is going to be taking a look at what the actual engine RPM is at. It's going to be varying the drive-by-wire throttle body opening, so the throttle plate opening. It's going to be adjusting that either open or closed more to allow more or less airflow in to be able to hit this desired idle speed. So we're going to have the first part of idle control is going to be airflow based. So we need a certain amount of airflow into the engine to make a certain amount of torque so the engine is going to idle to where we'd like it to idle at. Now, the next portion of this is going to be spark timing related. So if we jump up here and we jump into the timing table, we have a high octane timing map. And we're going to find here that this is going to have an idle area here for spark timing. We're going to find here that it's going to be between 500 and 1,000 is generally where we're going to have our idle RPM at. And we're going to have our load here between 0 and roughly 50 in the load. So this would be, in general terms of an Evo 10, where you would find your idle spark timing at. Now the idle spark timing here, as we learned about our spark timing, if we have higher values or higher advanced values, that's going to be generating more cylinder pressure. If we generate more cylinder pressure, we'll produce more engine torque. Likewise, if we have lower values here, let's say we're at going from 10 to 5, that'll produce less cylinder pressure and less engine torque. So this area of your spark timing table will have an influence on how much idle torque you'll make. Now, what's going to be to note here is that when we request a certain idle RPM and we have a certain amount of spark timing, the drive-by-wire throttle body will open a certain amount to get that airflow in. If we move or alter our spark timing here at our idle, it will affect the throttle body opening. So if we bump our spark timing up, and let's just say we're already hitting our target RPM here of roughly 900, we're requesting here, and we bump this idle spark up here to 15 degrees or 20 degrees, we're going to find it produces more engine torque. We're going to naturally start to overshoot this target RPM here, and we're going to find that. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.